Hello everyone, I'm back, and today we'll learn how to add steering to our car. But before that, I would like to implement something first. In our last video, we made our car be able to move. However, as you can see, it doesn't stop when we stop pressing the acceleration key. It just keeps sliding forever. To fix that, go to the wheels script and below the acceleration function call here, call a new function called apply z-force. We're gonna create it in a minute, and as parameter, pass the collision point. Down here, create the function with the same name we defined above. The first thing we need to define inside our new function is the direction. In our case, it's gonna be the global basis z, and we need the global velocity of this location. However, unlike other engines, Godot doesn't have a built-in function that does that, so let's implement one. Let's create the getPointVelocity function here, pass the point as a parameter, and the body of the function is really simple. We just return the car linear velocity plus the cross product between the car angular velocity and our position. To define our z-force, just use the dot product between the direction and our calculated velocity, because we just care about the forward velocity, and then multiply it by how strong we want to negate the movement in the z-axis. In a more realistic physics, that would be the tire friction plus air resistance, this kind of stuff. But in our case, we just will use a fraction of our car mass. You can play with this value and choose what works best for you. Okay, let's continue. Now we can apply the force to our car. We want to negate, so use the inverse direction times the force and pass the position. Let's also add our debug arrow graphics so we can understand what's happening. Let's use this point variable here as the position so that the line is not drawn on the floor, but a little higher at the wheel center position. Multiply the force by 2 so we can see it better. Let's run the game. Let's move the camera to the side so we can see better. You can observe we now have that pink arrow representing the new force trying to stop our car. And as soon as I stop pressing the acceleration key, the car starts to decelerate so it doesn't slide forward or backward forever. Great! Now let's implement our steering behavior. First, add two new actions. Let's call them turn left and turn right, and bind them to the keys A and D. Back in our card script, add three new export variables. The first one is the steering angle, which is the maximum angle we can rotate our wheels. Set the default to 30. And the tire grip for the front and the rear. You can let the default value as 2 and also add the steering input variable to receive our input. Now, inside the process function, let's get the action being pressed. Pass the two new actions we've just created so we can define our steering rotation by multiplying it times the steering angle. Now let's get the reference to our front wheels. Then check if we are steering. If so, let's rotate our wheels. First, define the angle, which is the wheel rotation in the y-axis, plus the steering rotation. However, we want to clamp this value with minimum to our negative steering angle and maximum to the positive steering angle. Let's create a new variable here called new rotation, and it's just the angle times delta. After that, let's set the rotation of the wheels, passing the new rotation, but we want to lerp the value so they rotate smoothly. Pass the current Y rotation and our new rotation, and then the interpolation value. Now do the same thing for the front right wheel. Before testing the game, let's add a new mesh to our wheels so we can visualize better what's happening. So I will add a new cylinder here, change the rotation to 90 degrees, decrease the radius of the cylinder and lower its position a little, and just give it a new color like blue so we can see the z-axis, and duplicate it and put it inside the front right wheel. And now we can test the game. Press A and D and we can see our wheels are turning. However, they don't go back to the default position. Before fixing that, let's just adjust our mesh here. I think they are too big, so let's decrease their sizes and also lift a little their position. To make our wheels go back to the default rotation, just set the new rotation to 0 when we aren't pressing anything. Let's test again. Press the keys, and as soon as we stop pressing the keys, the rotation gets back to 0. But now, even though we have our wheels turning, if we try to drive our car, it doesn't behave as one would expect. Well, This happens because there is no lateral force being applied yet. Let's fix that. Go to the Wizard script and create a new function called apply x-force, passing delta and the collision point as parameters. Define the direction we want to apply the force, which is the global basis x. We also need the tire world val, so you can copy from the other function. The lateral force will be the dot product between the direction and the tire world val, because we just care about the lateral velocity. Now create a variable grip, which receives by default the rear tire grip value. However, if this is a front wheel, we want the front wheel tire grip instead. Now define the desired val change, which is the wheel inverse lateral velocity times the grip value. Just sum it with delta and we have the x-force. Finally, apply the force to the car. Since the x-force is already negative, we don't need to negate the direction. Pass the position the same as always. Let's also add our debug lines. You should be familiar by now how it works. Just pass the initial position and the end position plus our force, and this time let's choose a different color like red. Okay, we have the values here, so let's run the game. Let's drive the car, and it is turning, however, is almost flipping, and it just did. Okay, to fix this, we need to load the center of mass of our car. Go here at the center of mass mode and change it to custom, and change the Y value to a negative value. Normally I choose the same or a higher value than the suspension length. Run the game. And now our steering is much more stable. However, if the car is still trying to flip, try to lower more the center of mass. Let's now move our camera up so we can see better. See, our red lines indicates the force being applied. It's working, but it is kind of boring. Let's make it a little more fun. To do that, let's first increase the engine power for something like 4 and decrease our rear tire grip to 0.5, 0.4, something like that. And let's try again. Let's elevate the camera so we can see it better. And now, as you can see, we have a kind of drifting car. So our car slides more at the back, and we can try to do a donut here. So let's increase the engine power a little more so we get faster. And you can play with these values to see one that you like more. And that's it for today's tutorial. I hope you enjoyed and see you later.